Okay, this is classwork 2.9 or 2.10, depending on what period you have me. Of course, you know the routine, write this work, and then I'm going to give you an example of one to try right away. All right, and of course, write down the 5 secret words. All right, here we go. We're looking at movements. So the first one is the translation, the slide, where again, I'm taking this object right here, if I could try to show you, and I'm just sliding it. I'm sliding it like up here, or I'm taking that and from there sliding it over here. So I need you to know that a slide is a translate. All you're doing is sliding it. What we're going to do is we're going to have you label that. This is A, B, C. This is what's called the pre-image, before it was moved. Pre-image. First word is blue. Blue. The image is after it's moved. This is the pre-image. We're going to tell you how to translate. We could tell you in words. We're going to say translate. Write this down. Translate 5 units right. And then from there, 4 units down. Write that down. Another way we could show that is x plus 5. That means you're taking every coordinate and you're changing it by 5. And then y minus 4. Another way of showing that translation, how you're moving it. Write 5, 4 down. That means every single point in this triangle is moving right 5, down 4. The way I would do it is just do it by points. Take each point on a little ride. I'm taking this first point A, right 5, 1, 2, 3, 4, 5, and then from there down 4, 1, 2, 3, 4. This is going to be its new home. We call that A prime. B, same little motion. 1, 2, 3, 4, 5, down 4. 1, 2, 3, 4. This is where the new B, his little home, is going to be. We call that B prime. And then C, same thing. 1, 2, 3, 4, 5, down 3, which gives me that triangle just moved. That's to the right 5, down 4. We call this the image. Write that down. Image, where it moved to. What we're going to have you know, because you're smart, is knowing what's going on with these coordinates. So let's look at pre-image coordinate A is -5, 1 for x and y. That's the coordinate. When I go to the new A prime, that point is 0, -3. What happened to every single x coordinate right there? It got plus by 5. It went to the right 5. That's why I get a 0 right there. Every single y coordinate went down 4. That's why I get that -3. Every coordinate is being added by 5 for x and subtracted by 4 for y. Again, when we start looking at coordinate recognition, again, moving to the right 5, down 4. I'm going to have you do the same for this triangle right here. This is A, this is B, this is C. I'm going to tell you how to move it. Translate 6 units left, so you're moving it to the left, and then 2 units up. And again, another way of showing that is x minus 6 and then y plus 2. Again, you're moving this pre-image. You're translating it. Every single point, 6 to the left, up 2. That's going to be the new image. All right, next kind of problem. Next word is dog. All right, the reflection. The reflection, we're going to tell you what line we want you to reflect over. We're going to write that for you. We're going to say reflect. And I'll write this. Reflect over the, start out with the y axis, the y-axis. This is the y-axis right here. This is the x-axis. If I'm flipping it, that means I'm taking this triangle. If I could try to show you and get all fancy with my high-tech software. A flip means I'm taking that and flipping it over that y-axis line. That's what I'm doing. I'm flipping it over that y-axis line. I'm not sliding it. I'm not moving this. Nope. I'm flipping it. A mirror image. A flip, a reflection has equal distance on either side of that reflection line. That's a reflection. If I wanted to reflect this over instead, maybe the x-axis instead, this is the x-axis right here. If I'm flipping over that to get a mirror image, remember, you're not sliding it. Sliding it, a translate is just moving it to a different spot. Same look. That's a translate. We're doing a flip. Let me try to show you high-tech fanciness. This is a flip, if my computer lets me. That's a flip over that y-axis, equal distance. Every point is the same distance on either side of that reflection line. So here we go. This first one, I'm having you reflect over the y-axis. Reflect over the y-axis, which is this axis right here. I'm going to have you label this again as A, B, C. This is the pre-image. I'm going to have you reflect over that y-axis, which means each new little point is going to be equal distance on the other side of that line. So the new C is going to be one box to the other side of that line, straight across. You don't want to do something jacked up, kind of diagonal, straight across. The new B is going to be 3 boxes to the left, or to, I'm sorry, opposite side of that line to the right. And then the new C, be careful, the new A, don't put it right there. That would make it a translate. Don't put it right there. The new A is 1, 2, 3, 1, 2, right here. That will make sure you get that clearly reflected image, flip image, where you could fold it down that red line and have it fold right on top of the other. And then, of course, high tech, what you need to know. This coordinate A, look, starts at -3, 1. When I reflect over that y-axis, I get 3, 1, where again, ooh, look, the x number became opposed, but the y stayed the same. Only the x1 became opposed. So again, we need to start working on point recognition now too, because you've seen these before. All right, I'm going to have you for this one. This is going to be A. Call this B. Call this C. I want you to reflect over the x-axis. Over this x-axis line right here. This is the y-axis. Reflect over the x-axis for this one. All right, last one. Here we go. This one is the most high-tech. Next word is red. This is the rotation. We're going to tell you how to rotate. We're going to always rotate around this middle point here at this level of math. We're not going to rotate around any other coordinate. So we're going to tell you how to rotate. So how do we write this down? Rotate. We're going to tell you how many degrees. It will be either a quarter turn, half turn, 3/4 of the turn. We're going to tell you the direction. This is going to be clockwise, which is spinning to the right like a clock does. A clock hand goes clockwise. That's clockwise like a clock. So we're going to do a quarter turn, spin to the right. And again, I need you to really focus. This is the tough part, the math, what we're going to really focus on. When you do a spin to the right, I want you to notice what's going on with these coordinates. And then here's where you really need to know coordinate aware of this. Let's look at that point 5-4, which I'm eventually going to call A right there. 5-4. When I rotate a quarter turn to the right, watch, those points are going to flip-flop, and that right one's going to be oppo. That tip of that triangle, a quarter turn to the right. And again, remember, I'm doing a quarter turn to the right. From here being 0 degrees, this being 90 degrees, quarter turn to the right. Watch, that's what I'm doing for this one. Quarter turn to the right. Puts that right here, using my software best I can. That was a quarter turn to the right. Now look at that new spot down here, right here. Look, look. That is 4, -5. Here we go, sports fans. What you need to know, when you flip it to the right, the points flip-flop. That X and Y number flip-flop, and then after you flip-flop it, that right one becomes oppoed. Always, that's what happens. So every coordinate is going to flip-flop, and that right coordinate is going to become opposited. All right, if I could show you another one here. This one shows what happens when you do a quarter turn to the left. Quarter turn to the left, and we would say 90 degrees counterclockwise. That's how we would write it. My pen will let me. I would write 90 degrees counterclockwise if I wanted you to do a quarter turn spin to the left. And again, watch what happens at that point. 5-4. It's gonna flip, and that right one, that left one is gonna become opposited. Watch, it's gonna rotate quarter turn to the left this time. Quarter turn to the left. We're not doing a half turn. Here's a 180 degree turn. That's a 180. We're doing a quarter turn to the left. Quarter turn to the left right there. And again, I need you to see what's going on with that coordinate. That coordinate that used to be 5-4 for this one now is -4, 5. Look, the coordinates flip-flopped, and that left one became opposited. That's what happens. That's what we're going to be memorizing, and I'm going to be yelling, of course, out here for a million years. All right, but here we go. Make this more complicated. Let's have you get rid of this right here. Thank you for listening. We're going to do a quarter turn to the right. There's one of my new coordinates already. I'm going to call this A, call this B, call this C. This is my pre-image. We're going to do a quarter turn to the right, where each point is going to be flip-flopped, and that right one becomes opposited. So there's the new A. Let's do it for C here. C used to be 1 for X, 2 for Y. So if this theory works, I'm going to flip it so that 2 is going to come over here, and that 1's going to come over here, and then that right one's going to be opposited. So it's going to be 2, -1. 1, 2 becomes flip-flop 2, 1, but then that right one becomes negative. So 2, -1. That's the new C prime's home. And then, of course, if I do 1, 4, again, that's the original pre-image point, 1, 4 for B. The new B should be flip-flopping that 4, 1, and then that right one becomes opposited. So 4, -1 right here. That's the new home for B prime. That's how we want you to memorize rotating quarter turn to the right, where the points flip and that right one becomes opposited. Or, of course, we'll start having you do quarter turn to the left, where the point flip-flops and that left one becomes opposited. All right, I'll be saying that a lot. Next word is gray. Gray. I have one more word. All right, here we go. For this one, I'm going to have you make this A, B, C, and we're going to do another quarter turn to the right. Rotate 90 degrees clockwise. Whoops, if I could spell. to the right. That's 90 degrees clockwise to the right. If we want to get fancy, we'll put CW for clockwise and CCW for counterclockwise. Quarter turn to the right. Doing a quarter turn to the right. Most of these are a quarter turn to the right or a quarter turn to the left. That's what we're really focusing on. But this one, quarter turn to the right. Every one of those coordinates is going to flip, and that right one becomes opposited. All right, last word is cat. Cat. Thanks for listening. This is just the beginning. Good luck.